Welcome to the AWS Certified Cloud Practitioner Prepcast, where we guide you through everything you need to know for your certification exam. Whether you're just starting or looking to refine your knowledge, this course will set you up for success. Brought to you by baremetalcyber.com. Let's get started. Amazon Route 53 is AWS's Managed Domain Name System, or DNS, designed to make domain management and traffic routing both simple and powerful. At its most basic, DNS translates human-friendly names like example.com into IP addresses that computers understand. Route 53 takes this familiar role and extends it with advanced, policy-based routing features that allow organizations to steer user traffic intelligently. Beyond resolving names, Route 53 can distribute traffic across multiple endpoints, detect failures, and guide users to the most responsive servers. By integrating with other AWS services such as CloudFront and Elastic Load Balancers, Route 53 provides a seamless way to connect users with applications while maintaining resilience and performance. Its global infrastructure ensures queries are answered quickly from the nearest location, aligning well with modern demands for availability and low latency. Route 53 supports both public and private hosted zones, offering flexibility for internet-facing and internal use cases. Public hosted zones manage DNS records for domains visible on the internet, like websites or email services. Private hosted zones, by contrast, are tied to one or more VPCs, making their records available only within those networks. This distinction allows organizations to use DNS not just for customer-facing applications, but also for private internal name resolution. For example, a company might use a public zone for its main website while maintaining a private zone for internal services, such as db.corp.local. Understanding when to use public versus private zones ensures DNS remains both secure and aligned with intended scope. The foundation of any DNS service lies in its record types, and Route 53 supports a full range of them. The A record maps names to IPv4 addresses, while quadruple A records do the same for IPv6. C name records create aliases pointing one name to another, such as www.example.com to example.com. MX records define mail servers, enabling email routing, and TXT records store arbitrary text, often used for verification or security frameworks like SPF and DKIM. In AWS, Route 53 also introduces alias records, which extend DNS functionality by allowing root domain names to point directly to AWS resources like CloudFront distributions or S3 buckets. These record types form the building blocks of DNS, and Route 53's support ensures compatibility with both traditional Internet standards and AWS's cloud-native integrations. Simple routing in Route 53 provides the most straightforward configuration, directing traffic to a single healthy endpoint. This model works well when only one resource needs to serve requests, such as a static website or a single load balancer. Route 53 performs health checks to confirm endpoint availability, ensuring users are not sent to failed servers. For example, if an application runs entirely in one region, simple routing ensures queries resolve directly to that endpoint. While this approach lacks complexity, it provides clarity and reliability, especially in smaller deployments. Its simplicity makes it the default choice when advanced routing isn't required, delivering stable, predictable behavior. Weighted routing introduces flexibility by allowing traffic to be split among multiple endpoints based on percentages. This feature is particularly useful for testing new versions of applications or gradually rolling out features. For example, you might direct 90% of users to the current production servers and 10% to a new environment for validation. By adjusting weights, teams can perform canary or blue/green deployments without risking full-scale outages. Weighted routing can also distribute load across regions or clusters, aligning traffic with business priorities. This controlled approach turns DNS into a traffic management tool, giving operators levers to experiment and balance workloads. Latency-based routing is designed to improve user experience by directing queries to the region with the lowest latency for each user. Because Route 53 relies on its global infrastructure, it can determine which endpoint is closest in terms of network responsiveness, not just geography. For example, a user in Europe querying a global application might be routed to AWS's Frankfurt region, while a user in Asia is directed to Singapore. This minimizes lag and ensures applications feel responsive regardless of user location. Latency-based routing exemplifies how Route 53 goes beyond traditional DNS, turning it into a performance optimization tool for global applications. Failover routing leverages Route 53's health checks to provide high availability. In this configuration, DNS records point to a primary endpoint under normal conditions, but automatically switch to a secondary endpoint if health checks fail. For instance, if a web application hosted in one region goes down, Route 53 can reroute traffic to a standby deployment in another region. This model transforms DNS into an active participant in disaster recovery, reducing downtime without manual intervention. While failover at the DNS layer cannot guarantee instantaneous switchover, it provides an additional safety net, ensuring users continue to be directed to functioning resources during outages. Geolocation and geoproximity routing policies extend control by steering users based on their physical location. Geolocation maps queries to resources depending on where the request originates, such as directing European users to European servers. Geoproximity adds further refinement by considering both location and proximity bias, allowing operators to shift traffic toward specific regions intentionally. For example, if a region has excess capacity, administrators can bias traffic toward it even if another region is slightly closer. These policies are especially valuable for regulatory compliance, where data must remain in certain jurisdictions, or for tailoring user experiences to local requirements. Multi-value answer routing provides another layer of availability by returning multiple healthy endpoints in response to a query. DNS resolvers can then choose among these addresses, spreading traffic while improving fault tolerance. For example, if a company runs 3 application servers, Route 53 can return all their IPs, and clients will attempt another if the first fails. While not as sophisticated as load balancing, multi-value answers provide a lightweight method of distributing traffic and enhancing resilience. This approach demonstrates how even basic DNS behaviors can be extended for availability when combined with health checks. Health checks in Route 53 are fundamental to many of its advanced routing policies. These checks monitor endpoints by sending HTTP, HTTPS, or TCP requests, determining whether they are responsive. If a health check fails, Route 53 can reroute traffic based on the configured policy, whether failover, weighted, or multi-value. Health checks can also trigger CloudWatch alarms, integrating DNS health with broader observability systems. For example, if a website's primary load balancer fails, Route 53 can redirect traffic to a backup, while CloudWatch alerts operators to investigate. Health checks thus transform DNS from a static system into a dynamic, health-aware traffic manager. DNSSEC, or DNS Security Extensions, adds cryptographic signing to DNS responses, ensuring queries are not tampered with en route. While DNS alone provides no guarantees of authenticity, DNSSEC allows resolvers to verify that answers come from legitimate sources. In Route 53, enabling DNSSEC means AWS signs your hosted zone, providing protection against attacks like cache poisoning. While not universally required, DNSSEC is increasingly seen as a best practice for securing domain resolution. For organizations handling sensitive workloads, it provides an additional layer of assurance, complementing TLS encryption at the application level. Time to live, or TTL. Settings define how long DNS responses are cached by clients and resolvers. Short TTLs provide agility, allowing records to be updated quickly, but they increase DNS query volume. Long TTLs reduce query load and improve performance, but make changes slower to propagate. For example, during a migration, administrators might shorten TTLs in advance so cutovers occur quickly, then increase them afterward for stability. TTL strategy thus balances responsiveness with efficiency, shaping how quickly the DNS system adapts to change. Understanding TTL behavior is vital for managing user experience during updates or failovers. Route 53 also supports resolver query logging, giving administrators visibility into which domains are being queried within a VPC. These logs can help troubleshoot application behavior, detect misconfigurations, or provide forensic evidence during security investigations. For instance, unexpected queries to external domains might reveal misbehaving software or compromised instances. Logging transforms DNS from a passive service into a source of operational intelligence, ensuring name resolution aligns with expected usage. This transparency is critical for both troubleshooting and governance. Finally, naming conventions play a subtle but important role in DNS management. Clear, consistent naming ensures that administrators and developers can easily identify and manage records. For example, using prefixes like app1.prod.example.com or db.dev.example.com distinguishes environments and services, reducing errors. Naming hygiene becomes particularly important as organizations scale, preventing confusion or misrouting. Combined with tagging in AWS, consistent names form the backbone of operational clarity. DNS is as much about human readability as machine resolution, and thoughtful naming conventions ensure it serves both effectively. From an exam perspective, Route 53 often appears in questions about matching routing policies to requirements. If the goal is resilience, failover is the answer. If the goal is low latency, latency-based routing applies. Weighted routing fits gradual deployments, while geolocation or geoproximity aligns with regulatory or user targeting needs. Recognizing which policy solves which problem is the key skill, turning DNS from a generic service into a flexible traffic director. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. Private hosted zones are one of Route 53's most valuable features for internal applications. By linking a hosted zone to a VPC, you can provide DNS resolution that is accessible only inside your private network. This allows developers and administrators to use friendly names such as db.internal.corp instead of memorizing IP addresses. Private hosted zones can be associated with multiple VPCs, supporting multi-VPC architectures where internal services span environments. For example, a private zone might allow application servers in one VPC to resolve database names in another without exposing those records publicly. This separation ensures external users see only what's meant for them while internal teams benefit from consistent, private name resolution. Split horizon DNS patterns extend this concept by serving different answers for the same domain name depending on where the query originates. For instance, internal users might resolve app.example.com to a private IP within a VPC, while external users resolve the same name to a public-facing load balancer. Route 53 supports this by using separate hosted zones, one public, one private for the same domain. This pattern is especially useful for hybrid applications that must be reachable both inside and outside corporate networks. It prevents the complexity of managing different names while maintaining secure separation between internal and external connectivity. Route 53 resolver endpoints add another dimension by bridging DNS between AWS and on-premises environments. Inbound endpoints allow on-premises servers to query Route 53 for private hosted zone records, while outbound endpoints forward AWS queries to on-premises DNS servers. Together, These endpoints enable hybrid DNS architectures where workloads across environments resolve names consistently. For example, an AWS-based application might resolve an on-premises Active Directory domain, while on-premises clients resolve VPC-hosted private services. This integration prevents DNS silos, ensuring hybrid networks behave like unified systems. In increasingly hybrid IT landscapes, resolver endpoints play a key role in operational continuity. Hybrid DNS often requires forwarders to ensure queries are routed to the correct place. With Route 53 outbound endpoints, AWS workloads can forward queries to on-premises DNS systems for domains not hosted in Route 53. Conversely, inbound endpoints let on-premises systems forward queries to Route 53 for VPC-hosted records. For example, a company might forward all queries for .corp domains to Route 53 while sending external queries to existing on-premises resolvers. This dual integration ensures DNS resolution remains accurate and predictable across hybrid environments, reducing misconfigurations and simplifying administration. Weighted routing policies make blue, green, and canary deployments straightforward. By assigning percentages to different endpoints, teams can gradually shift traffic during deployments. For example, an organization might start by sending 10% of users to a new version of an application while the rest remain on the stable release. If issues arise, traffic weights can be adjusted back instantly. If the rollout succeeds, traffic can be shifted fully to the new version. This approach provides agility without compromising availability, giving teams confidence to innovate while minimizing risk. DNS becomes more than just resolution. It becomes a release management tool. Multi-region failover architectures rely on Route 53's health checks and routing policies to provide continuity during outages. In this design, DNS directs users to the primary region under normal circumstances but shifts to a secondary region if health checks fail. For example, an e-commerce platform might serve users from its U.S. region but redirect to Europe if U.S. systems fail. While DNS-level failover is not instantaneous due to TTL caching, it provides a valuable recovery mechanism that integrates cleanly with AWS's global footprint. Combined with other disaster recovery strategies, it ensures users always land on a functional endpoint. Logging DNS queries provides visibility into application behavior and aids in troubleshooting. Route 53 query logging can capture which names are being resolved, how often, and from where. For example, an unexpected surge in queries to an unfamiliar external domain could indicate malware or misconfigured software. These logs also help during forensic investigations, offering evidence of attempted communications with external systems. Beyond security, query logs also reveal optimization opportunities, such as services making redundant DNS calls. Logging turns DNS from a silent background service into a source of operational and security intelligence. Security around DNS updates is just as important as query controls. Route 53 integrates with IAM to enforce least privilege for DNS changes. Administrators can define fine-grained permissions, allowing some users to view records but not modify them, while others can create changes only in specific zones. Change sets further support governance by staging updates for review before execution. For example, a developer might submit a change set to update an A record, but an administrator must approve it before the change takes effect. These controls reduce the risk of accidental misconfigurations or malicious tampering, keeping DNS trustworthy and predictable. Costs in Route 53 are tied primarily to query volume, health checks, and advanced routing features like geolocation. Each DNS query incurs a small charge, which can add up in high-traffic environments. Health checks also contribute to costs, as they continuously probe endpoints for availability. Geo-proximity routing introduces additional expenses for advanced features. For example, a global gaming platform serving millions of queries per minute must factor query costs into its design, perhaps caching DNS results with longer TTLs to reduce calls. Understanding these cost levers helps architects balance responsiveness with financial efficiency. Integration with AWS services extends Route 53's utility. Alias records allow direct mapping of domains to resources like CloudFront distributions, application load balancers, or S3 buckets without needing static IP addresses. This integration ensures DNS remains aligned with elastic AWS services, where endpoints may change dynamically. For instance, instead of hard-coding an IP address for a load balancer, an alias record points directly to it, simplifying management and improving resilience. This capability underscores Route 53's role as more than a traditional DNS. It is tightly woven into AWS's service ecosystem. Disaster recovery strategies benefit from Route 53's failover policies. By combining health checks with standby resources, organizations can design systems that automatically redirect traffic during disruptions. For example, a financial application might replicate to another region and configure failover records so that if the primary becomes unhealthy, DNS resolves to the backup. This design adds resilience without requiring manual intervention, aligning with business continuity goals. While not a substitute for comprehensive DR, DNS failover provides a simple, effective layer of protection. Governance practices ensure DNS changes don't introduce instability. Approval workflows, version-controlled records, and rollback strategies allow administrators to manage updates safely. For example, before migrating traffic to a new endpoint, a team might shorten TTLs and document rollback plans in case issues arise. Tagging hosted zones and records helps track ownership, preventing confusion about who is responsible for specific domains. Governance ensures DNS remains reliable, reflecting the principle that even small misconfigurations can have broad impacts when dealing with global name resolution. One common pitfall in DNS design is attempting to use CNAME records at the zone apex or root of a domain. DNS standards prohibit this, but Route 53 addresses the issue with alias records, which provide similar functionality while remaining compliant. For example, instead of creating a CNAME for example.com pointing to a CloudFront distribution, an alias record is used. Misunderstanding this difference often causes issues in domain setups, but knowing to use alias at the apex solves the problem neatly. This is a frequent exam and real-world scenario, highlighting the value of AWS-specific extensions. Monitoring DNS performance involves more than just uptime. It includes user experience. Perceived latency, the time it takes users to reach applications, may vary depending on routing policies. For example, a misconfigured latency-based policy might inadvertently send European users to a US endpoint, increasing response times. CloudWatch metrics and third-party monitoring tools can measure resolution speed and accuracy, ensuring routing policies deliver the intended outcomes. Monitoring confirms that DNS not only resolves correctly but also optimizes user experience in practice. From an exam standpoint, Route 53 questions often test the ability to match routing policies to requirements. Weighted routing aligns with traffic splits, latency-based improves performance, failover ensures availability, and geolocation satisfies jurisdiction or localization needs. Scenarios involving hybrid DNS, split horizon designs, or apex records often test whether learners know when to use private zones, resolver endpoints, or alias records. By connecting requirements directly to Route 53 features, exam candidates can answer with confidence, mirroring the reasoning real architects use when designing systems. In conclusion, Amazon Route 53 combines traditional DNS functions with advanced routing, integration, and security features. Private hosted zones extend DNS to internal networks, weighted and latency-based policies optimize traffic, and failover provides resilience. Resolver endpoints and hybrid patterns make DNS consistent across cloud and on-premises environments. Governance and cost management keep DNS reliable and efficient, while monitoring ensures it delivers the intended user experience. By understanding Route 53's full toolbox, Organizations can turn DNS into a dynamic, policy-driven control point, aligning traffic with health, latency, compliance, and business goals. That concludes today's episode of the AWS Certified Cloud Practitioner Prepcast. Be sure to tune in for the next episode and visit us online at baremetalcyber.com or cyberauthor.me for more resources, including news, mailing lists, YouTube videos, podcasts, and much more.